everyone. Hope you're not missing school too much. Today we're going to talk about our brand new unit, which is our Unit 8. And in this unit, we're going to talk about our radicals. So we've done things like we've simplified fractions and we've simplified polynomials, and we're just trying to simplify, this time, rational expressions. So day 1, simplifying radical expressions. Now, for this course, we are only really going to talk about simplifying square roots. Okay, so we're going to start with a square root. And the symbol we're going to use looks like this, the square root of x. And what a square root does is it finds the length of a side of a square, given its area. So in our last unit, when we were talking about radicals, we did things like if I had a box with 1, so the square root of 1 is 1. If I had a box with 4 squares, the square root of 4 would tell me that there were 2. 1, 2. Again, I can go on and on and on, right? I can go by a 3 by 3. So now I have 9 squares. The square root of 9 is 3. So remember all of those numbers that we referred to as perfect squares. So perfect squares. So 1's a perfect square. 4's a perfect square. 9, 16, 25. So now 6 squared, 36, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared, 14 squared, 15 squared, and so on and so forth, right? These are all numbers that are squared, right? So things like x to the second, x to the fourth, x to the sixth, x to the eighth, and so on forever, right? So anything that has an even exponent is going to be considered a perfect square. So we know things like if I want to take the square root then of 81, I want to think about a square that has 81 squares in it. That has to be a 9 by 9. So my square root of 81 is 9. Now, technically in the math world, we also have a negative 9. We're going to refer to this one, though, as our principal square root. So we're pretty much going to consider the positive one unless there's a negative on the outside of our parenthesis. So if I have something like negative square root of 144, well, I'm going to keep that negative there, and I'm going to say that that's negative 12, right? If I have something, let's say I have a number on the outside of my radical. This is 3 times the square root of 100. So this is the same thing as 3 times 10, which would give me 30. You may see sometimes they're written as plus or minus the square root. Let's do something like 225. And I would just give my answer as plus or minus 15, meaning I have a positive 15 or I have a negative 15. Now, notice that these were all really nice ones. They all worked out to really nice answers. But now we have to think about, okay, well, what if they don't work out to be nice answers? So what if I have a square root that's not a perfect square? Okay, so to simplify, square roots. All right, so the first thing we're going to do when we're simplifying a square root is evaluate if it's a perfect square. Okay, so if the value under the radical, call that the radicand. If it is a perfect square, we do it just like we did above. If it is not a perfect square, we need to write the equation or the expression in what we call simplest radical form. So think about it like a fraction, like it's the most reduced fraction that it could be. Okay? So to get this in simplest radical form, all right, so what we'll do is we'll do an example. All right, so for example, let's say I have the square root of 12. Now 12 is not a perfect square. So the first thing we want to do is we want to find the largest perfect square factor. So if I think about the largest perfect square factor of 12, I know that that's the square root of 4 times the square root of 3. So what I'm doing is I'm rewriting as a product. So what I want is I want the square root of the perfect square times the square root of the non-perfect square. If they were both perfect, we would have already simplified this. We wouldn't have had to do this. Now, this one is my perfect square. So the square root of 4 is now 2, and this one has to just stay radical. Whoop, not a radical 2. So that's going to stay a radical 3. So my answer is 2 radical 3. So what I did there was number 3, we simplify the perfect square. And then we write it as a product. All right, so let's try another example. All right, so within our second group of examples, call this example 2, I have the square root of 50. Now, if you're not so sure how to get all of the factors of 50 or how to try to find the biggest one, what we're going to do is we're going to go to our calculator. In our calculator, we're going to go to y equals, we're going to take our number 50, we're going to divide by x, and we're going to take a look at the table. So if I take a look at my graphing calculator, I go to y equals, and I do 50 divide by x, and I go to my table. I now see all of my different factors of 50, all the things that multiply to 50, looking at just the whole numbers. So I notice that I have a 2 times a 25. There we go. So what I'm going to do is I'm going to break this up into a radical 25 times a radical 2. Here's my perfect one. So this is a 5 radical 2. We can check in the calculator if the decimals are equal. All right, so a nice little double check for us. All right, let's try a third one. Let's say I give you radical 32. So I'm looking for the biggest perfect square that goes into 32. All right, so that's going to be radical 16 times radical 2. So my answer is 4 radical 2. Now, if you happen to do that problem, and let's say you thought about this and you thought, hey, this is actually 4 times 8. You're right. It's absolutely 4 times 8. But now I have 2 radical 8. But radical 8 still has a radical 4 times a radical 2 in it. So now this is 2 times 2 radical 2, which also gives me 4 radical 2. Notice I get the same exact answer. It just took me another step to do it. Okay. What if I have a number out in the front? So let's say I put a number here. So let's say 3. And we're going to do radical. Let's do 28. So what I'm going to do is I'm going to bring the 3 down. I'm going to break this into radical 4 times radical 7. That 4 is the perfect one. So 3 times 2, radical 7, giving me 6 radical 7. All right, now the next set of examples are going to have some letters in them. Okay, so for my next example, we're going to use the radical. We're going to do 200 times a to the 6th. All right, so what we're going to do is we're going to take the number just like we were doing before. So radical 100 times radical 2. Now, a to the 6th is actually a perfect square. So a to the 6th is going to get its own parenthesis because it's even. Now, these two are the perfect ones. So now I have 10 a to the 3rd radical 2. So whenever you have a polynomial and you're taking the square root, you just cut that number in half. Okay, let's try another one similar to that. Let's try the square root of 72 x to the 5th. Now, notice this is an odd power. So first, we're going to worry about the 72. And the 72 is 36 times 2. Now the x to the 5th. Notice that it's odd. What's going to happen there is I'm going to break this into x to the 4th and an x. So I pull out the biggest even number that I can. So now I'm looking for which ones are going to be perfect. So perfect, perfect. This is going to give me a 6 and an x squared. And everything else that didn't make it out stays underneath the radical. All right, number 7, let's try the square root of 24c to the 10th. Now notice that's even. So I break down 24 using radical 4 and radical 6. And this one just gets its own, c to the 10th. It is perfect. So now square root of 4 is 2. Square root of c to the 10th is c to the 5th. Radical 6 stays under the radical. And that's my answer. Number 8. Let's do the square root of 75. Now let's use more than one variable. This time let's do an x to the 2nd, y to the 7th. So I'm going to break my 75 into a 25 and a 3. This is an even, so it gets its own parenthesis. This is an odd, so this is going to be a y to the 6th and a y. Now again, perfect, perfect, perfect. So 5x, y to the 3rd, radical 3y stays under the radical. There's my answer. All right, let's try number 9. This one I'm going to give you 64, a to the 9th, b to the 10th. Now 64 is perfect. So the square root of 64 is going to be 8. Now the a to the 9th, there's an odd. So I want an a to the 8th and an a. B to the 10th is even, so b to the 10th gets its own. Perfect, perfect, perfect. So 8, a to the 4th, b to the 5th, radical a. All right, and our last one for today, number 10. We're going to put a number on the outside. I've got a 20. X, y to the 5th. All right, so that 3 is going to come down. That 20 is going to turn into a radical 4 times radical 5. The x is going to stay in its own parenthesis. And the y to the 5th is going to turn into a y to the 4th and a y. Now I look for the perfect ones. Perfect, perfect. So now I have 3 times 2 times y squared. Gather up everything else. I do want to take care of this right here. So now this is a 6, y to the 2nd, square root of 5xy. All right, email me if you have any questions.